Hey everybody. Let's see. So Boomer and I, and here's Boomer. Hey dude. Boomer and I are going to teach this really quick lesson on the law of conservation of mass, which covers reactants, products, and balancing of chemical equations, or making sure that they're balanced. So let's go ahead and get started. Okay, the law of conservation of mass is freakishly important. Okay, so that's, this right here. And it says that mass is not created nor destroyed in chemical reactions. And so what that means is that the number of atoms, so, we've been counting atoms, we've been practicing that. The number of atoms before a chemical reaction happens, and that's your reactants, must be exactly the same as the number of atoms after a chemical reaction, because you cannot create or destroy matter, right? And that's what this is saying. So, first of all, just a quick review. You should know this already from the lesson like on Monday or Tuesday. Reactants are what goes into a chemical reaction. That's what you have before. So like the example I use is if I'm baking a cake, all the ingredients, the egg, the sugar, the flour, all that stuff, that's the reactants. The product is what I get out of it. Well, when you have a chemical reaction shown, and that's this, okay, so that's a chemical reaction, you're going to start seeing something in the middle, an arrow. All right. And that arrow is the chemical reaction, right? And so what happens is everything before that arrow is the reactants. So all this stuff, this is on to the left of the arrow, to the left, to the left. All right. So that's the reactants. Okay. Everything to the right of the arrow or after the arrow, that's going to be your products. So that's what comes out of it. For example, right here, what this is showing is we have two molecules of H2. They react with O2, and then that gives you two molecules of H2O, two molecules of water. So if we were doing the baking a cake thing, everything on this side, on this left side, that would be my egg and flour and all that stuff. And on this side, the product would be the actual cake, right? So again, reactants are always on the left or before the arrow, and the products are always on the right or after the arrow. So here's an example. If you have, a butamous picture, right? Then you've got everything to the left. See, there's our arrow. Everything to the left of that arrow is the reactants, and everything to the right is the products. So even if you see that in picture form or model form like this, everything to the left is the reactants, and everything to the right of that arrow is the product. Okay. Here's another example. Now, this actually has three different versions on it, right? You've got the models. See? You've got the written out chemical formula, and then you've just got the names of them. And so for all of those things, we have stuff all the way over to the left. That's the reactants. My glorious handwriting. And everything over to the right is the products. Wow. All right. And so, there's our arrow right there. Okay. So let's practice finding out whether chemical equations are balanced or unbalanced. Now, here's what I mean. Like I said up here, the number of atoms before a reaction occurs must be exactly the same as the number of atoms after a reaction. All right. So if they're equal, then it's balanced. If they're not equal, then it's unbalanced. So let's look at these. We've got two chlorine atoms, right? So if I were to, write this out, I'd have H and then Cl and then H and then Cl. So I've got two chlorine atoms on the reactant side, and I've got two hydrogen atoms. Okay, well, on the product side, I have one. So I've got 1, 2 chlorine atoms, and then 1, 2 hydrogen atoms. That is a balanced equation. That is balanced because the number of atoms on the reactant side and on the product side are exactly the same. And that's extremely important, right? Because that shows the law of conservation of mass. That shows that no mass was created nor destroyed in that chemical reaction. So let's look at this one. All right. So how I do this normally, and this is going to be harder because we're not in person, is I normally just draw a line. All right, and you don't even have to know. And so like I draw the line under the arrow, right? So there it is. And on this side, I'm going to type on the left side the reactants. I'm going to write the number of atoms on that side, and on the product side, I'll do the same thing. All right, now you don't even have to know what these elements are. You can just call them by their color. So I'm going to have R for red. That's clearly an R. Oh my gosh. And then I'm going to have W for white. So let's count the number of red ones on the left side on the reactants. So we got 1, 2. And then we have 4 white ones. 1, 2, 3, 4. All right, so on the product side, let's see if it's balanced. All right, so on the white side, we have 1, 2, 3, 4. And for the red, we have 2. So that is a balanced equation. That does show the law of conservation of mass. Isn't that nice? Smile. All right, so let's look down at this one. This one has a lot more. I'm going to draw my line, and I'm going to say we have red atoms, we have gray atoms, and we have white atoms. Okay, so on the reactant side, let's count. Our red ones, we have 1, 2, 3. On the grays, we have dos. And the whites, we have 1, 2, 3, 4, 5, 6. All right. So over here, this might be something that you need scratch paper for, by the way, this stuff. All right. So we've got red, 1, 2, 3. Grays, 1, 2. And white, we have 1, 2, 3, 4, 5, and 6. So that is another balanced. Clearly, that's a B. That is another balanced chemical reaction. That's good. All right, now you're also going to see them in this form. In fact, this might be the kind that you use most. All right, so let's do this. Here's our arrow. So I'm going to draw my line. Okay, so we've got the reactants on the left and the products on the right. And we have, it looks like 2 different elements. We have nitrogen and we have oxygen. Nitrogen and oxygen. Okay, so then remember we've got our coefficient here. This is a coefficient, and we've got a subscript here. Coefficient, subscript, okay. So the coefficient, if you remember, it multiplies everything after it. Now, we have a plus over here. That means nitrogen is reacting with the oxygen. So the coefficient is only going to apply to this section right here. And so like this coefficient, though, this one is going to apply to this whole thing because it's together. But this one's separated by the plus sign right there. And so that means that this coefficient's only going to apply to what's immediately after it, not anything after the plus. So we have 2 times 2, right? So that gives us 4 nitrogens. Oxygen has nothing after it, so there's only 1 oxygen on the reactant side. Let's look at the product side. We have 2 times 2 for nitrogen. That gives us 4 nitrogens, so far, so fantastic. But we also have 2 times 2 oxygens, or 2 times 1 oxygen, I'm sorry. There's nothing after the oxygen, so there's 2 times 1. So that gives us a grand total of 2 oxygens. This one is not balanced. Okay, so this is not balanced. This is bad. It does not show the law of conservation of mass. What this shows is that 1 oxygen atom is created, and that is simply not possible. Okay, not possible, so that's unbalanced. All right, here's a big beastie one. We got lots of coefficients and subscripts here. That's why I chose this one, actually. So I'm drawing my line, and then we have Y and R. That's our 2. Clearly, that's a Y. That's our 2 elements there. Okay, so let's start with the reactant side. Well, their Y is only in one place. We don't have any over there, so there's 8 times 1y, which is 8, right? Now, again, this coefficient does not apply over here because there's a plus sign in the middle, okay? All right, so then let's figure out our r. So we got 6 times 2r, meaning 6 times 2 is 12. So we have 12 of those and 8 of those. All right, product side. Now hold up. This coefficient is going to apply to the entire thing because there's no plus sign, right? This is all one thing. There's no plus sign, separating. So 4 times 2y is 8. And 4 times 3r is 12. So this one is balanced. Yay! This one is a balanced chemical equation. It does show the law of conservation of mass because the number of atoms before the reaction and the reactants are the same as the products after the reaction. Okay, you guys are now going to have some practice to do on your own. If you've been following along with this video, all the answers to the Google form in section 1 are there, okay? It is now your all's job to use what you have learned from this video to answer the questions correctly in section 2. Good luck. May the Lord of the balanced stuff be with you.